All right, so we want to look at this problem here. In fact, let me zoom in on this. Now we see the answer here, but we're going to look at this problem: 3 times the square root of 24 minus the square root of 96 plus 3 square roots of 54 minus the square root of 12. And what we're going to do is we're going to use our rules about exponents to make this into a simplified solution. So let me put it here. 3 square roots of 24 minus square root of 96 plus 3 square roots of 54 minus square root of 12. Now, we want to think of this thing using some of the terminology that we picked up as 4 separate terms. So I'm going to work with each term to simplify the radical expression. And then we're hoping that some of these have the same radical expression so we can then collect like terms. So I'm going to start with this term, and I'm going to work with this term next, and so on. I'm going to work my way left to right. And so 24 has a perfect square in it. Well, if I do my division trick, the perfect squares under it are 16, 9, and 8. But 8, or not 8, 9, and 4. 4 is the next perfect square. And so 24 is a combination of 4 times 6. All right, and what I meant by the division trick was I write all my squares and I divide the squared part into 24, and the first one that divides in evenly, well, that's going to be the part that comes out, and that's going to be the part that's left inside. Now, when the square root of 4 is 2, so I get 3 times 2 times the square root of 6, or 6 root 6. So I've worked on the first term. Now I'm going to work on the next term. And so we do the same thing with 96. So let me continue my squares here. So I want to divide into 96. 64 doesn't divide evenly. 49 doesn't. 36 doesn't. 25 doesn't. 16, 6 times 6. So this is 6 times 36, right? Because 6 times 6 is 6. Carry my 1. Nope, that's too big. 16 is what I wanted in there. 6 times 6 is 36. Carry my 3. 6 times 1 is 6, plus the 3 is 96. And so the 16 is the perfect square, so 4 comes out, and I have a square root of 6. And so now I have that term. And we'll continue over here. And so 54. So 36 doesn't go into 54. 25 doesn't go into 54. But 4 times 16 goes into 54. Because 4 times 6 is 4. Carry my 2. No, it doesn't. Oh, I'm trying so hard. Well, at about 9. And this is why having a calculator helps. 9 goes into 54 6 times. So 9 times 6. Or 9 comes out as a 3. 3 times 3 root 6. Or 9 root 6s. And then root 12, well, that's 3 times 4. And the 4 is a perfect square. So that comes out as 2 root 3. And now I have 4 terms, but I have like terms here. I have 3 like terms and 1 different term. So 6 minus 4 is 2. 2 plus 9 is 11. So I have 11 square root of 6's here. 11 square root of 6's. And then this 2 root 3 I can't do anything with. And that's the simplest answer I can get from this. And if we look at our result here, okay, that's the answer the book was looking for in simplified form. And so this is what we do with radicals. We turn them into like terms, and we work our way through the terms, hoping to get them to the most simplified state.